Assalamualaikum warahmatullahi wabarakatuh. According to the latest projection of UN Water Development, the global population could grow to around 8.5 billion in 2030, 9.7 billion in 2050. The equivalent of almost 3 planets could be required to provide the natural resources to sustain current lifestyle. 93% of the world 250 largest companies are now reporting on sustainability. So less than 3% of the world's water is fresh, which is drinkable, of which 2.5% is frozen in Antarctica, the Arctic, and glaciers. Humanity must therefore rely on 0.5% for all of man's ecosystem and fresh water needs. Humankind is polluting water in rivers and lakes faster than nature can recycle and purify. More than 1 billion people still do not have access to fresh water. Excessive use of water contributes to global water stress. Water is free from nature, but the infrastructure needed to deliver it is expensive. Water has been increasing worldwide by about 1% per year since the 1980s. Agriculture, including irrigation, livestock, and aquaculture, is by far the largest water consumer, accounting for 69% of annual water withdrawal globally. Industry, including power generation, accounts for 90% and household for 20%. Over 2 billion people in countries experiencing high water stress over the period 1995 to 2015, floods accounted for 43% of all documented natural disasters, affecting 2.3 billion people, killing 157,000 and causing $662 billion in damage. 3 out of 10 people, 2.1 billion people, or 29% of the global population, did not use a safely managed drinking water service in 2015, whereas 844 million people still lack even a basic drinking water service. Therefore, we need to save water so that the future generation will be able to use hygiene water. So in IIUM, traditionally manually operated taps cause people leaving the taps running, scaring themselves with water that's too hot, or splashing water over the washroom. People just turn on the tap when this leads to wastage of water in the university. Everyone opens the tap while taking ablution, brushing teeth, and washing hands. In other words, they do not use water within their needs. So we came up with an idea to implement a sensor water tap in IIUM.
There are a few challenges. Firstly, the main challenges is about the movement control order that happen right now. For example, it is hard and difficult to apply for this project at IIUM since we are restricted from going to IIUM. Also, the three of us are living in a different state, which I am in Selangor, one of them are in Perak, and the other one is in Kedah. Hence, the communication among us is quite limited since we are only communicate through online platforms. The next challenges is the pedal might be easily broken if people are using it non-stop, or if people step on the pedal too hard, it may cause the pedal broke or not function. Therefore, the pedal might have to be replaced frequently. There, if there are excessive use of the sink, therefore, if the pedal are broken, the sink will not function at all. Lastly, the last challenge is it will involve a lot of cost at first, since there are a few construction that need to be done in IIUM in order to change the old water system to the foot pedal sinks.
Considering all the challenges that may be faced to implement the project of sensor water tap in IIUM as mentioned by one of my group members, we agreed to modify this project and implement it at home by using equipment which is cheaper and easy to find. Here, we transform the common and normal sink into another different sink which is more practicable, and we name it Step on Sink. Actually, we got the inspiration to implement this sink from the idea of Step on Bin, which has the same concept with our project, that is cleanliness without touching the bin, and of course in our project, cleanliness without touching the sink. For your information, this is a low-cost project because we only use a material which is cheaper and easy to find, such as spring, faucet, cable, and pipe. We were also able to prove the effectiveness of this project. We do an analysis on the quantity of water consumption by step-on sink compared to common or normal sink. Analysis the effectiveness of the step-on sink project. As shown in the graph, step-on sink use less water compared to common sink. For example, washing dishes by using common sink requires about 20 gallon water. Conversely, step-on sink requires only about 15 gallon water. Hence, step-on sink is more effective in terms of water consumption, user-friendly and eco-friendly. First, step on the pedal using one of your feet. You can control the water pressure with your own feet. When you step on the pedal, water will come out. If you do not want to use the water, move your feet away from the pedal. So, the water will stop flowing.
Okay, moving on to the benefits. Sensor taps significant water savings to conserve water. Sensor taps generally include an aerator in the spot which disperses the water and means that much less is needed for washing than is the case with traditional taps. This means that sensor taps generally have a much lower flow rate than traditional hand-operated basin taps. Traditional taps can use up to 10 to 15 liters of water per minute. In comparison, the water taps overflow rates of as little as 2 liters per minute, up to 70% less than traditional taps, and our Miski taps use around 60% less water than traditional taps. Furthermore, sensor taps are more energy efficient. Sensor taps enable you to keep water at a constant temperature, so you don't need to expend energy changing the water temperature. For this reason, taken as a whole, they tend to be much more energy efficient than traditional hand-operated taps. Besides, sensor taps are cleaner and more efficient. Another difference between sensor taps and traditional tap is that the flow rate of sensor taps is predetermined, whereas for traditional taps, the user has to select their preferred flow rate every time. Presetting the flow rate also prevents the user from selecting a flow rate that's too powerful, which helps to reduce splashing and means that the bathroom stays cleaner. In addition, sensor taps are much more hygienic. As already discussed, hygiene is one of the key benefits of sensor taps. The user is not required to actually touch the tap with their hands at any point during the hand washing operation. This means that there can be no cross-contamination between users. Additionally, products such as those in our Miscare range take this further by enabling hands-free dispensing of soap and other cleaning liquids as part of a single hand washing operation. Overall, however, we find that modern hand-free taps are very intuitive to use and completely remove many of the user error problems that can occur with traditional manually operated taps, such as people leaving the taps running, scaring themselves with water that's too hot, or splashing water over the washroom. Even though there are a lot of benefits to implementing a sensor tap everywhere, especially in IIUM, there are also a few challenges that we must note to implement it to our university.
For the recommendation, our group recommendation to implement the foot pedal sink is parallel to the purpose of this project, which is to reduce the water usage in IIUM. Furthermore, the foot pedal sinks will avoid a high water pressure flow even if the pedal are being overstepped. In addition, the university is encouraged to implement this project, food pedesting, in the mahala, to be applied in the mahala, the food court, and the mosque. This is due to many cases where the students forgot to turn off the pipe properly and there are still a dropping of water. Hence, the implementation does reduce the water usage and also to avoid the water from being wasted. In conclusion, there are a lot of benefits of implementing this project, and most importantly, to avoid the water from being wasted, also to reduce the water usage as stated in the mission of the SDGs 12, clean water and sanitation, which is to ensure the availability and sustainable management of water. Thus, the benefit of this project is to ensure the community in IIUM health since they don't have to touch the sink directly to avoid the bacteria and the viruses from spreading to one another, especially during this pandemic of COVID-19. Last but not least, this project should be considered by the university authority to implement this food pedal sink since there are many benefits if we implemented it in a long term. That's all from our group. Thank you.
That's all from us. Thank you.